Okay, quick review before we get started. We are going to look for the missing side C, yes. However, you need to remember that C is indicated as the hypotenuse or the longer side. A is going to be said to be the smaller side and B your mid sides. Okay, and we've already studied our Pythagorean triples at this point. Okay, so what we need to do is also remind you that C squared is C times C, which is a double of C. Now, we also know that if we take the square root and put C squared under it, puts the C double under it, in the end, we get C. So let's think about this as far as looking at our triple, and we've only have variables. So we haven't put numbers to it yet. So we can apply the same thing. So if we put each side under the square root, why are we going to do both sides? Well, we have to keep balance on each side of the equal. So if I put under the square root, C squared on one side, then I'm going to put all of the other side under the square root. So I have A squared first, plus B squared. Okay, what's going to happen here? I can pull C out because that does undo it. What I've done, per se, we've undone the C squared, so we just have C. But the other side, we can't do that. But it is helpful because, let me go ahead and rewrite this. If you can remember this, that C equals A squared plus B squared, all under the square root. So then what we're going to have now is, by example, let's say, okay, that I have C, but I'm going to make A equal to 3 and B equal to 4. So on this side, I have 3 squared plus 4 squared, and that's going to mean that my C is going to be under the square root 9 plus 16, which equals the square root of 25. Okay, wait a second. Isn't that the double? 5 times 5. Let me rewrite this a little better. Well, we already know that 5 times 5, we're going to undo that. That means that C equals 5. So that would mean that we have a triple that is a 3, 4, 5 right triangle. By this time, you should have already seen one of those. Okay, next slide, we'll move on to just finding A. In this slide, we're looking for the missing side, A. We need to recall that any variable squared under the square root will simply equal that variable. Now, we need to point out the obvious. B squared minus B squared is going to equal 0. We call this a zero pair. This is a common term used in algebra. So let's begin by applying that. We need A all by itself on the left side. Please notice that I have flipped this equation around so that we have A squared plus B squared on the left side. So we need to apply that zero pair to B squared. So if we subtract B squared to each side, this means we will keep this equation in balance. So let me show you. Now we have B squared minus B squared. This is going to equal that zero pair that we are looking for. So let's rewrite this without the 0. We do not need the 0. So now we have A squared equal to C squared, C squared minus B squared. This is exactly the form we need. So now if we apply the first concept we talked about, squaring on both sides. So let's make a square on both sides. Now we have both sides under the square root. We can apply this term, take the a out, and that will be equal to, under the square root, c squared minus b squared. So now we have some kind of an equation to help us find out what a is. So let's test that. So if we say that c is equal to 5 and b is equal to 4, we will have a is equal to, let's see, 5 squared minus 4 squared, and that will equal, that's 25 minus 16, and that just so happens to be 9 squared. 9 squared, if we pull that out, that is equal to 3. So now we have a is equal to 3, which should look familiar from the last slide. Okay, on this slide, we are looking for the missing side, b. Again, we need to recall that the variable, or any variable, b squared under the square root will simply be the variable itself, in this case, b. And again, we will be using a zero pair. On this slide, our zero pair is a squared minus a squared is equal to 0. So let's apply that to our formula, because we are looking for b on its own. So we need to apply minus a squared to the left side, as well as the right side. Okay, and that's on each side of our equal. Now we will rewrite, go down a little further. This means that I do not need to write this 0 outcome, our 0 pair. A squared minus a squared is equal to 0. We don't write that. So now we have b squared, changing colors, is equal to c squared minus a squared. So we apply the concept that if we put each side under the square root, we will simply have b on its own on the left, because we can pull that out from under the square root. It undoes itself. And now we'll have on the right side, under our square root, c squared minus a squared. This gives us something usable. So if we say that c equals 5, as before, and a equals 3, as before, we can substitute in, and we have under the square root, we have 5 squared minus 3 squared, and that will equal, under the square root, 25 minus 9, which equals 16 under the square root. If we bring that out of the square root, we know that b will equal 4. Now we need to summarize our other slides. And in those slides, we found that a is equal to 3. B was equal to 4. Let's write this better again. And B is equal to 4. C was equal to 5. And we can prove this to ourselves above we know that 3 times 3 is 9, 4 times 4 is 16, which equals 5 times 5, which is 25. Okay, so let's write out our final formulas that you should have in your notes. So you should have A was equal to the square root of C squared minus B squared, and B is equal to under the square root C squared minus A squared. And for C, you should have C is equal to under the square root A squared plus B squared. Okay, now let's make some observations before we finish. Let's look at this. For each formula, yes, they are all under the square root. Okay, so we should at least remember to do that. And then for C, that was not difficult because we're going to take our existing formula, put it underneath the square root, but please note a difference. You have a plus. But if we look at our other two final formulas, we have a minus symbol between our C squared and our other squared. So let's look at this. Okay, for A and B, yes, you have a minus symbol, okay? And they both begin with that C squared. So they both begin with C squared right here. They're both going to have a minus symbol. However, this last observation tells us that if we need A, we're going to subtract B squared. If we need B, we're going to subtract A squared. Okay? And this, for C, that's different. You're just squaring what you actually have. Okay, this should summarize everything that you need to know. Make sure you have all this in your notes.